Hello everybody and welcome back to this tutorial. And right now what we are going to do is we're going to take a more advanced look at defining sockets. Now what we did in the previous tutorials is we saw how we can create a simple program that is going to be a program that is going to basically send and receive messages from one PC to another. Now what we did in order to implement that, we created a socket object. We also created a while true loop that is going to receive and send data. I also showed you some of the ways how you can actually implement more different things except actually sending just messages, such as for example changing the directory, writing to files, or executing some different commands. Now right now we are going to take a look at the more advanced sockets. Now basically what we did in the previous tutorials is the TCP server and client implementation. We saw how we can actually create the connection via three-way handshake, and then basically we processed into actually sending and receiving messages. Right now, let us take a look at some of the partial reads and writes in the advanced sockets. Now, socket programming can usually be a little bit difficult. It is often a mess. There are a huge number of options, many corner cases, as well as many failure modules or reliability issues. Now, be aware that the read and write function, or the reading and writing to a socket, may involve partial data transfer. Now, what I mean by that is that the send function that we saw previously, let me just open up my idle, open it up right here, and that the send function, so, oops, import socket. Okay, so finally the send function that we actually used in order to send data, that function will actually return actual bytes sent. So for example, if we have a string that's going to be the actual length of, let's say, 8 bytes, the send function will return the actual amount of bytes that were sent, which is 8 bytes. So let us see how we can do that just by simply, let me just create the socket real quick. We will just simply establish a connection. I will not explain anything that I'm doing because we already passed this, for s.bind, and we will bind my IP address, which is 192.168.1.6, and then we will go to the 6789, let's say that port. Now we are going to listen for two connections, doesn't even matter, and client's address will be equal to sock.set. Press your enter. Let us just create real quick the client, which is going to connect to the actual socket, or to the actual server that we coded right here. All of these things should already be familiar to you as we did them before. So let me just socket.socket, socket.af_inet, socket.sock_stream, s.connect, and right after we connect, we should be able to establish a connection. So 1.1.6, make sure to check first of all what is your IP address, your local IP address, and that we already know we can do with the help of the command prompt, and then specify it right here, and then specify the port. Yeah, because we actually called it sock and not S. S is in our server, so let me just go right here, comma, and right now the port number, and we are good to go. We have established the connection. So right now let us create a data, a simple data that we are going to send to our server. So right here, let's say we have data equals hello world. Press here enter, and basically if you just type here length of data, you will see it is the length of 11 bytes. Okay, and now if we simply just want to send this data, we can do that just by specifying s.send data. But before we do that, let us create client.receive 1024 bytes will be data. Now the server is waiting for the message from client, and now if we send the data, Yeah, it is sock.send. Once again, it is not s.send. A byte object is required. Yeah, we will actually have to encode it because we are using Python 3. Therefore, it has to be encoded in order to be able to transfer it over socket. And we can see that the actual send function prints out right here that 11 bytes were sent. Now we received right here, and if we just type length of data, we can see that we also received 11 bytes. Okay, so now if we actually decode this, because we can't really print, if I just type here data, you will see that it will print it out with db right before it. That means that the data has to be decoded. Therefore, we need to just simply type data.decode, and we can decode it with the UTF-8. So we can see the amount of bytes that the actual socket has sent over network. As we can see, the length of the data that we received is 11 bytes, and if you simply just count letters in the hello world, we will receive 11 bytes. And basically, the same goes with the send function. It will by default, if you don't specify anything else, it will output the amount of bytes it has sent. Now, the only reason why this amount of bytes is equal in both of these programs is because we used the encoder. Now, if we didn't use it, well, for example, in Python 2, you can send the data without encoding stuff, and there, the actual send and receive function will not be the same length. So, for example, the send function will print out a different value for the same data than the receive function will print out once we actually receive it. So, for example, the send will type that it sent 11 bytes, while as the data will print out less or more bytes than that. Okay, so basically those are partial writes and reads. Now also be aware that for TCP, the data stream is continuous, so no concept of records. What that means is basically once you send data and you send more data, the actual server that is receiving the data, so let's say the client sends something as it did right here, and the server needs to receive it, the receive function may return data from both of the sends combined, or less data than even the first send. Okay, so you can just simply see right here, if we specify that the data will be equal to client.receive, we want to receive 1000 bytes. Okay, and let's say that the actual client sends sock.send, it sends data.encode, or let's just type here, let's first type two strings, string 1 equals hello, string 2 equals world. And now we first want to send the string 1, which we will have to encode UTF-8. And now we send the string 2, which we also need to encode UTF-8. And you will notice that we in total sent 5 plus 5, we sent 10 bytes in total. So these two strings have hello world. Each of them has 5 letters, and each letter represents 1 byte. Therefore, we have 10 bytes in total. But if you just print data right here, you will see that we only have the word hello right here. That basically means that as soon as the actual server received something, it closed the connection and it stored the value right here, and it wasn't trying to receive no more. So if you try to send multiple stuff like this, it will not work. It will only store the first stuff. Now, a lot of that depends on the OS buffers, the network bandwidth, and the actual congestion. So if you want to, for example, send all data, to wait until all data is sent, you can use send all. Now, it will block until all data is transmitted. For most normal applications, this is what you should basically use. Now, the only exception is you don't want to use this if networking is mixed in with other kinds of processing, such as screen updates, multitasking, and so on and so on. But even if you use the send all function, for example, a client wants to send multiple things and it uses send all function, and the server receives that, how can the server know when is the end of data. So how to tell if there is no more data that is going to come. Now this receive function will return an empty string once all of the data is sent. Now this means that the other end of the connection has been closed, so no more sends. In order to actually write this properly, you need to perform some data reassembly. So basically, receivers often need to reassemble messages from a series of small chunks. So right now we're going to see a programming example for that. So for example, let's say we have the max size value to be equal to 1024 bytes, okay? And then we have fragments, which is going to be the fragments of data. So right here, fragments equal, open and close brackets, we're going to create it to be a list of chunks. And right here, we're going to enter a while loop. So right here, we'll specify while not done. We're going to specify chunk to be equal to s.receive, or pardon me, client.receive, and we're going to receive max size, okay? This is our actual line that is going to get a chunk, and now we're going to check if the chunk is actually equal to, or if it doesn't exist. That means that we actually received all of the data. So if not chunk, we will break out of the loop. In any other case, we will append to our list of chunks, so fragments dot append chunk. That means basically right here, this break statement right here means that we no longer have any data to receive, therefore we're breaking out of the loop. So right here, press here enter, name done is not defined. Pardon me, I used the done, which we didn't really define, so let us do it like this, while not while chunk, or let me just see right here, we can specify while or let's just try with the while yeah, simply let us just go with the it is invalid syntax, so while true, let us go with the infinite loop. So while true, chunk will be equal to client.receive of max size. If not chunk, I actually wanted to use chunk as an actual parameter in the while statement, but let us see if this will work. So fragments.append chunk. Press here enter, and we can see that we are basically stuck right here because we are stuck on this statement right here, and therefore let us try to send something that is going to be a lot larger than 1024 bytes. Because if we actually send something that is going to be 1024 bytes big, it is going to store it simply because the actual max size is 1024 bytes. But what we are wondering is what happens if the actual data that we are going to receive is larger than this number. So in order to check that out, we can simply create a variable called data, or large data, let's call it like that, large data, and let's create it to be equal to a times 2000. Let me see right here, a is not defined. Yeah, we need to actually type it like this, large data equals a times 2000. Okay, so right now we have a large data variable that is stored the 2000 times a, so basically 2000 letters, which consist of letter a. That is 2000 bytes, therefore 2000 bytes is larger than 1024, and right now we will see if I just specify a length of large data, with d smaller d, okay, 2000, and right now if we just specify sock.send and we send large data.encode and we encode it with the UTF-8, Okay, let me see right here. For some reason it is still stuck right here, so if not chunk, let's try to keyboard interrupted, but for some reason it doesn't want to. Not really sure what is wrong right here. So basically we enter a loop, we receive the data, if not chunk, so basically if the data right now is no bytes, we will basically break out of the loop. In any other case, we will simply just fragments.append. So let's try to sock.send all. Let me just try something. Data equals a times 48. And if this works, I will simply just explain to you why I did this. But if it doesn't, we will simply just restart. Yeah, okay, it did work. And let me just explain to you why it did work. So basically, if I just get the length of the chunk, 976, which is weird. Okay, so we don't have the entire actual string printed out right here, which is a little bit weird, but this wasn't meant to be actual. But we'll see how we can actually do the correct way of this in the with the usage of the JSON library later on. For some reason, once it actually sends the entire data, it doesn't set the chunk variable to be equal to nothing. So basically to be equal to none. Therefore, we need to send the round number, and round number is 2 times 1024, which is going to be 2048. In order for chunk to be equal to nothing. And right here, let me just see right here, that's what we actually sent, and that's why it closed the while true loop. So you can see 2000 is what we sent from the first try, and from the second try we sent 48. Okay, so basically, let me try this one more time, just a little bit different. So while true, chunk equals client.receive max size. Okay, if not chunk, we're going to continue with this. We will break out of the loop, fragments dot append, we are going to append chunk, and then we're going to set the chunk to be equal to nothing. Okay, press here enter. Now we are waiting for the data. Let's say we send the data once again, so sock.send data.encode, and we encode it with the UTF-8. Press here enter, and now we send the large data as well, and we will see what is the actual size of that data that we receive. Oops, not data, we want large data.encode UTF-8. Okay, never mind, this didn't work. We will just close it right here. And we will see the actual true example, what I wanted to show you later on with the JSON library. I just want to show you the basic understanding behind it, but for some reason this doesn't seem to work. Maybe it is because we are using something as a list, but it really shouldn't be something like that. But we also made a mistake. Once we actually printed out the chunk, we should have printed out the fragments, because that is where we're storing our variables, or that is where we're storing our data, or basically the list of chunks. Now we're going to get back to this later on with the JSON library, but for now on we're going to make a pause, and we're going to continue in the next video with the timeouts and blocking sockets and so on and so on. Now we're not going to touch any of that in greater detail. Basically we're going to just take a look at it, and we're going to pass through different things that you might need later on. So hope you enjoyed this tutorial, and I hope I see you in the next one. Bye.